Hello, geometry students. In this lesson, we're going to talk about 8.3 notes. We're going to be talking about special right triangles. But before we get into our lesson about special right triangles, I need to talk with you about a little bit of arithmetic. So in today's lesson, we're going to come across some expressions that might look like this. For example, you might see something like 5 times the squared, or not, excuse me, 5 divided by the square root of 2. And whenever we have a radical in the denominator of a fraction like this, this expression is considered not simplified. This is not a simplified radical. And the reason why is it's not because there's anything wrong with having a radical in the denominator. The reason it's considered not simplified is because this represents division by an irrational number. The square root of 2 is approximately equal to 1.4142135, and I'm just going to put ... because this is actually an irrational number. These decimals would go on forever and ever and ever. So can you imagine taking the number 5 and dividing it by 1.4142135, etc. That just represents really, really awkward arithmetic. So what we do whenever we have a radical in the denominator to simplify that is we do a process called rationalizing the denominator. Now, before we rationalize a denominator, we're going to actually take this denominator and turn it into a rational number. I just need to talk about one property with you, and that is if you take the square root of a number and square it, you're going to get that number back again. Think of it this way. This square and this square root are inverses of each other. So if you start with a number, take its square root and then square it, you're going to get right back with right back to where you started. Or think of it this way. The square root of a squared means the square root of a times the square root of a, which is the square root of a squared, which is a. So however you look at it, anytime you take a number, you take a square root and you square it, that will get rid of the radical. That will get you back to the number. So we're going to use that idea here we're going to actually, it's called rationalizing the denominator, because we're going to change this denominator from an irrational number to a rational number just by squaring it. So what we're going to do is we're going to multiply that denominator by the square root of 2. But as you learned in grade school, I can't just multiply the denominator by the square root of 2. I also have to multiply the numerator by the square root of 2. Because what I'm actually doing is I'm multiplying the number by 1. Square root of 2 times the square root of 2 is 1. So if you take anything and multiply it by 1, you don't change the value. We're just changing what it looks like. So what we end up with is 5 times the square root of 2 all over 2. And that is considered simplified because taking this numerator and dividing by 2, now we're just dividing by 2 instead of dividing by a number like this. All right. So I just wanted you to see that arithmetic, this idea of rationalizing a denominator. We're going to have to do it several times in this lesson. So let's get back to our notes, and we're going to start with this idea. Let's take an isosceles right triangle, which is what this is. And in an isosceles right triangle, as we see below, we're going to use the Pythagorean theorem to express the hypotenuse h, which is this, in terms of one of the legs, either one of these. Okay, so using the Pythagorean theorem, the Pythagorean theorem would tell us that if we take that hypotenuse and square it, that is equal to the sum of the squares of the two legs. Well, these two terms are like terms, so we can combine them together. So we would get that h squared is equal to 2 times l squared. Okay, now I'm trying to express h in terms of l, so I need to solve for h. Right now, h is being squared, so to undo that, we are going to take the square root of both sides. So we would get that h is equal to, I'm going to go ahead and break this up to the square root of 2 times the square root of l squared. Now, remember, we just talked about this, the square root of l squared would just be l. So I'm going to go up here and rewrite this as h is equal to the square root of 2 times l. Okay, so what we have done is we have just used the Pythagorean theorem to derive our first theorem for the day. It's called the 45-40-90 triangle theorem. In other words, whenever we have a right triangle that has that's actually isosceles because it has two 45-degree angles. So whenever we have a 45-45-90 degree triangle with legs L and hypothesis H, or I'm sorry, not hypothesis, hypotenuse, I'm sorry, the result is that H, the measure of that hypotenuse, is always going to be the square root of 2 times one of the legs. So in other words, this is like a shortcut to the Pythagorean theorem. Whenever we are dealing with a 45, 45, 90 triangle, we can always just use this relationship that the hypotenuse is equal to the square root of 2 times one of the legs, and we don't have to use the Pythagorean theorem. So for example, take a look at this theorem. This right triangle. It's got a 90-degree angle and a 45-degree angle, so we know that this other angle has to be a 45-degree angle. So it's one of our special right triangles, a 45, 45, 90, where we know one of the legs and we want to know x, the hypotenuse. Well, since x is the hypotenuse, to find that leg, or excuse me, to find that hypotenuse, all we need to do is multiply the leg times the square root of 2. So our hypotenuse x is just equal to 6 times the square root of 2. We just took the leg and we multiplied it by the square root of 2. Let's try it again in this triangle. We can see that this triangle is an isosceles right triangle, so that means that these two acute angles are both going to have to be 45 degrees. So in a 45, 45, 90 triangle, we know that the measure of the hypotenuse is equal to the square root of 2 times one of the legs. So our hypotenuse, which is x in this problem, is equal to the square root, one of the legs, 9 times the square root of 2 times the square root of 2. So we just take a leg and multiply it by the square root of 2. Well, we can combine these. The square root of 2 times the square root of 2 is 2. So this is equal to 9 times 2, which is equal to 18. Okay, so let's take a look at another example. Okay, here we have again, we have a 45-degree angle and a 90-degree angle, so this angle has to be 45. So it's a 45, 45, 90 right triangle where we're being asked to find the hypotenuse x. So to find that hypotenuse x, we just need to take one of the legs, which is 4, and multiply it by the square root of 2. Okay, same thing in letter D. To find x, just take one of the legs of 5 and multiply it by the square root of 2. So the hypotenuse measures 5 times the square root of 2. Now, in letter E, now we're going to go backwards. Here, we know what the hypotenuse is. In this example, we're being asked to find one of the legs. Well, notice the legs both measure x, so that makes this an isosceles right triangle. In other words, it's a 45, 45, 90 triangle. So now what we're going to have to do is we're going to have to go backwards. So 12 is equal to one of those legs times the square root of 2. Or in other words, to find the leg, we just need to take 12 and divide it by the square root of 2. Okay, so now this is one of those expressions we were talking about. There's nothing wrong with this. In fact, we could leave it like this. But if we were asked to put this in its most simplified form, we would want to represent a division not by a irrational number, but by a rational number. So we are going to do what's called rationalizing the denominator. I'm going to multiply both the bottom and the top by the square root of 2. And when we do that, we get, I'm going to go ahead and turn this around and say x is equal to 12 times the square root of 2 all over. Square root of 2 times the square root of 2 is 2. And then we can simplify this a little bit more because 12 divided by 2 is 6. So our final answer would be 6 times the square root of 2. So looking at example F, we can see it's a 45, 45, 90 triangle because these legs are the same. It's an isosceles right triangle where we know the hypotenuse. Now, if we knew one of the legs and we were looking for the hypotenuse, we would take a leg and we would multiply it by the square root of 2 to get the hypotenuse. This time we know the hypotenuse, so we need to get back to one of the legs. So we're going to go in the opposite direction. To find out what x is, we're going to take that hypotenuse and divide it by the square root of 2. And then, rationalizing that denominator again, let's multiply top and bottom by the square root of 2. So x would be 15 times the square root of 2 all over 2. And that would be our final answer. Okay, how about letter G? Again, we know the hypotenuse. We need to know one of the legs. So our theorem tells us take a leg, multiply it by the square root of 2 to get the hypotenuse. So if we know the hypotenuse and we need to get back to the leg, well, that's when we're going to divide. So to find out what that leg is, we'll take 5 times the square root of 2 and divide it by the square root of 2. Well, this time we have a common factor of square root of 2, which cancels, okay? So our final answer then is just x is equal to 5, okay? And then letter H, okay, another 45, 45, 90 triangle where we know the hypotenuse. We need to know what this leg is. So to find that leg, we're going to take the hypotenuse and we're going to divide it by the square root of 2. Well, I may have mentioned this in class, the following property, that the square root of a divided by the square root of b is the same thing as the square root of a divided by b. So in other words, this is the same thing as 3 times the square root of 6 divided by 2, or 3 times the square root of 3, and we can just leave our answer like that. Okay, so before we go on to our other special right triangle, I just want to summarize again. Anytime we have a 45, 45, 90 triangle, the hypotenuse is equal to the square root of 2 times a leg. So we have a little bit of space over here. Let's go ahead and draw an isosceles right triangle, okay, a right angle. And then one of the acute angles is 45 degrees and the other one is 45 degrees. So if the legs measure L and L to get the hypotenuse, we take the leg and we multiply it by the square root of 2. So now we're going to take a look at another theorem that involves our other special right triangle, and that is a 30, 60, 90 triangle. So as you can see in this picture, in a 30, 60, 90 triangle, this triangle is not isosceles. In fact, it's not going to have two legs that are congruent. It's going to have a long leg and a short leg. So the first thing we're going to do is identify, in a 30, 60, 90, identify the hypotenuse, the long leg, and the short leg. So I think everybody knows which one the hypotenuse is. It would be the side that is opposite the 90-degree angle. The hypotenuse will always be the longest side. So this is our hypotenuse, okay? Then we have a long leg and a short leg. Now, usually you can tell just by looking which one the short leg is and which one the long leg is, but the best way to identify a short leg is to find the 30-degree angle and look at the leg opposite that. So the short leg will always be the leg opposite the 30-degree angle. So this is our short leg, and then short leg, and then the long leg is going to be the leg that's opposite the 60-degree angle. So this is our long leg. So now let's do a little bit of work to see if we can derive our 30, 60, 90 triangle theorem. So if you take a look at this triangle, we've got a 60-degree angle here, a 60-degree angle here, and obviously this is going to be a 60-degree angle. But I'm not going to label that angle because I'm going to actually draw an angle bisector. I'm going to bisect that angle, which is also going to be an altitude. And so what I've created here, let me shade in, I've created a little right triangle. Okay, so this yellow triangle is a right triangle, okay? Oops. That has, obviously it has a 90-degree angle and it has a 60-degree angle, so this angle is going to be 30 degrees. So let's go ahead and label that angle as 30 degrees. Okay, now, I'm going to go ahead and call the measure of this altitude, I'm going to call it A, okay? Then the next thing I want you to notice is when I draw this altitude, which is also an angle bisector, we could use congruent triangles to quickly show that this segment has been bisected, that this is actually a midpoint. So I'm going to call this segment, I'm going to call it X, okay? And since this original triangle was equiangular, it was a 60, 60, 60 triangle, that means it is also equilateral, okay? So if this whole side measures X, has a measure, it would be the same as this whole side. And I think you can see that this whole side is going to be twice X. So I'm going to label this as 2X, okay? So that actually demonstrates the first part of our 30, 60, 90 triangle theorem, which talks about how we can express in a right triangle, we can express the hypotenuse and the long leg in terms of the short leg. So the first thing we can see in this yellow triangle is that the hypotenuse is twice the measure of the short leg. So in a 30, 60, 90 triangle, where the short leg measures x, the first part of our theorem tells us that the measure of the hypotenuse of that triangle is going to be 2 times the measure of the short leg. Okay, now let's talk about the long leg. Okay, so what we're going to do is we're going to use the Pythagorean theorem on this triangle. The Pythagorean theorem tells us that the square of the hypotenuse, the square of the measure of the hypotenuse, well, that hypotenuse is 2x, so I'm going to take that hypotenuse and square it, and that's going to be equal to the sum of the squares of the two legs. Well, the two legs are a squared and x squared. So now what we're going to do is we're going to go ahead and take this equation, we're going to solve it for a, because I want to get an expression for this long leg in terms of x. So we're going to solve this for a. So the first thing I'm going to do is I'm going to square, I'm going to square 2x, which means I'm going to take 2x and multiply it by itself. So 2x times 2x will give us 4x squared. So that's equal to a squared plus x squared. Then, since I'm solving for a, I'm going to subtract an x squared from both sides. So minus x squared minus x squared. That's going to give us 3x squared is equal to a squared. And then since I'm solving for a, I'm going to take the square root of both sides. Okay, and I'm going to go ahead and turn this around and write it as a equals the square root of 3x squared, or we could write that as the square root of 3 times the square root of x squared. And then I can simplify this, right? Because it's the square root of x squared, the result of that would just be x. So we finally get that a is equal to the square root of 3 times x. In other words, in terms of our picture, a is equal to the square root of 3 times x, where x is that short leg. Okay? So in a 30, 60, 90 triangle with the short leg x, the long leg, that would be this leg right here, a, the long leg is equal to, oops, I didn't mean to say a, hold on. Meant to say the long leg is equal to the square root of 3 times the short leg. Okay, so what I want to do to demonstrate that is let's just draw a picture of a 30, 60, 90. So we've got a little bit of space right here. So draw a right triangle that clearly has a long leg and a short leg. It has a long leg because one angle is 60 degrees, and it has a short leg because another angle is 30 degrees. Now, what this theorem does is it allows us to express both the hypotenuse and the long leg in terms of the short leg. So let's go ahead in this picture and call the short leg x. Then our theorem tells us that the hypotenuse is 2 times the short leg, and the long leg is going to be the short leg times the square root of 3. Okay, so that will always be the case, and so it's another situation where this is really just a shortcut of the Pythagorean theorem. So let's use that theorem now to find x and y in example A. So if you look at this triangle, you can see we have a 90-degree angle, a 30, and a 60. So this is a 30, 60, 90, where we know the short leg. 21 is the measure of the side opposite the 30-degree angle, so we know that short leg. Okay, so let's first of all find the hypotenuse. Remember, the hypotenuse is twice the short leg. In this picture, our hypotenuse is x. So the hypotenuse is going to be 2 times the short leg, or 42. So our hypotenuse measures 42. And now let's find the long leg. Well, the long leg is right here. It's opposite the 60-degree angle. Our theorem tells us that the long leg is the square root of 3 times the short leg. So to get that long leg, we're just going to take y, or to get y, we're going to take the short leg, which is 21, and multiply it by the square root of 3, and there's the measure of the long leg. Okay, then let's take a look at the next example. Okay, in this example, we know the hypotenuse, and we're being asked to find x. Now, x would be opposite this 30-degree angle. Let's go ahead and label that angle 30 degrees. So we're going to find the short leg, and then once we know the short leg, we can express or find a measure for the long leg. Okay, so since we know the hypotenuse and we know that the hypotenuse is twice the measure of the short leg, well, if we knew the short leg, we'd double it to get the hypotenuse. So to go the other direction, if I know the hypotenuse and I want to get the short leg, all I have to do is take the hypotenuse and take half of it. So our short leg would be 5. And then now that we know the long leg, our 30-60-90 theorem expresses the long leg in terms of the short leg. All we need to do is take the short leg and multiply it by the square root of 3. So to find our long leg in letter B, we just need to take that short leg, 5, and multiply it by the square root of 3. Okay, in this next example, we have, again, a 30-60-90 theorem where we don't know the short leg, but we do know the long leg. Now, and whenever you're dealing with the 30-60-90, if you don't know the short leg, that's what you want to find first, okay? So our theorem tells us that to get the long leg, we would take the short leg and multiply it by the square root of 3 to get the long leg. So that means if we want to go backwards, if we know the long leg and we need to find the short leg, we need to divide. So to find that short leg x, we're going to take the long leg and we're going to divide it by the square root of 3, okay? And then, as we mentioned before, there's nothing wrong with division by the square root of 3. It's just not very simple arithmetic. So what we're going to do is we're going to rationalize the denominator. We're going to just multiply it by itself. But whatever you do to the denominator, you also need to do to the numerator. So that means that our long leg is going to be 15 times the square root of 3 all over the square root of 3 times the square root of 3 would give us 3. And then that can simplify a little bit. That'll, since 15 divided by 3 is 5, our final answer would be 5 times the square root of 3. Okay? So our long leg is 5 times the square root of, or excuse me, not the long leg. We just found x, the short leg. It's 5 times the square root of 3. Well, now we know what the short leg is to find the long leg. To find the hypotenuse, remember our theorem says take the short leg and you double it to find the hypotenuse. So that means y is going to be 5 times the square root of 3 times 2. So our final answer would be 10 times the square root of 3 for the hypotenuse. Okay? And then let's try one more example. This is another example where we know the long leg. Okay? So the first thing you want to do is find the short leg. So again, to find, if you knew the short leg and you wanted to find the long leg, you would take the short leg and you'd multiply by the square root of 3 to get the long leg. Well, now we're going backwards. I know the long leg and I want to find the short leg. So I'm going to take that long leg, 12, and I'm going to divide it by the square root of 3. And then we'll rationalize that denominator again just to simplify a bit. So we would get 12 times the square root of 3 all over 3, and that simplifies to 4 times the square root of 3. So that is our short leg. And then we're being asked to find the hypotenuse. Remember, the hypotenuse is just twice whatever the short leg is. So to find y, we will take the short leg, which is 4 times the square root of 3, and we're going to double that. Okay, so our final answer would be 8 times the square root of 3. All right, so you're going to get a lot more practice in class tomorrow. So if you have any questions about these notes, you can ask me then.